So here's another equation we'd like to solve for x. X over 5 on the left side is equal to x over 3 plus 4. Your options: multiply both sides of the equation by 15, or find a common denominator for 3 and 5, or subtract 4 from both sides, or subtract x over 3 from both sides, or divide both sides by 4. So I'm not going to do the whole tally here, but just to note that 4 was the majority option. Sorry, the plurality. Anyway, this was the winner, and this one's in second place. Okay. Again, the good news is that whether you answered 4 or you answered 1, neither one of those is actually an incorrect way to go forward in a problem like this. Whether or not it's the most effective or the most efficient is a matter of taste. Let me first talk about option number 4. So if you chose that option, you were envisioning a way of moving forward whereby subtracting x over 3 from both sides addresses the problem that we addressed in our previous cue, right? Which is, we've got variables on both sides, let's try to fix that. And so you'll end up with an equation after the subtraction that looks like x over 5 minus x over 3 is equal to 4. And that's great. Again, we've addressed the problem that the x appears on both sides, and by subtracting, we've made it appear only on one side. But there's another problem, another practical problem with this equation that gives students of algebra fits, and that's the fractions. So somebody that picked option 1, tell me, what does option 1 do for you? It eliminates the fractions. Where does this number 15 come from in this example? 3 times 5. So it's a number which is both a multiple of 3 and a multiple of 5. I happen to prefer this as the first step, because the first thing that it does is it wipes out all of your fractions and lets you deal in just whole numbers. And anytime you can do that, it's a win-win, I think, for everybody. So just to take a look at what that would look like. The 15, again, which we got by finding a common multiple of 3 and 5. If I multiply by 15 on the left side and on the right side, then what do I get on the left side of my equation? 15 times x over 5 turns into 3x. Why 3?
Because, you just eliminate 5 to 1, and 15 just becomes 3.
Yeah, exactly. So we're just really multiplying the fraction 15 over 1 by x over 5, and then reducing the 15 by 5 on top and bottom. Or in other words, 15 divided by 5 gives us 3. But then that same 15 also has to multiply the two terms on the right-hand side. 15 multiplied by x over 3 is going to give me 5x. And then, and this is a step easily missed, 15 also multiplies the 4. 15 times 4 give me 60. So we haven't solved the problem of still having an x on both sides of the equation. But we have addressed what's, for I think most algebra students, the stickier problem, which is the appearance of these fractions. All of our fractions are now gone, and from here we can solve this using the strategy that we saw in the previous example, which is let's subtract either 5x or 3x from both sides to make it so the x only appears on one side of the equation.